Hello students. In the last slide we have introduced linked list. We have seen that why we should use linked list instead of using array list, and we have discussed some pros and cons of linked list. So and how we can overcome some limitation of array list or arrays by using linked list. We have discussed those sort of things. Now we also have seen that linked list basically is a set of nodes. So you will have several of nodes, and those nodes basically build a linked list. So today we'll see that how we can implement a linked list, or how we can insert anything a linked list, how we can delete a linked list. So those sort of things we'll see today. So and we will also have seen that how to search something from a linked list. So let's start with a single linked list operations. So we also have seen that what is the difference between single linked list and double linked list. Single linked list actually basically has one forwarding node informations, whereas a double linked list has two address. One is going to forward node information, or one is going to forward node, and another one going to backward node. So we'll talk about the double linked list later. Let's start with the single linked list. So, so for examples, in order to search something in the linked list, so you have to start from the starting point. So when you have a linked list, you need to maintain some starting point of a linked list, because it's not an array. So this is not a contiguous. All nodes in the linked list are scattered. So if you don't have address of the starting point, so probably you'll lose the you know you'll lose the you'll not find where is the linked list information, so where is the data. So you must maintain starting from the point of the linked list, and use the starting point, then use the all links, forwarding links, then you can traverse node by node, and you can easily find any data. For example, the starting point of this node is 0. So if you know the address of this node, then you can easily come to this node. Then using this node, and you can use the link to go to the next node. Then after coming there, you have the next node informations using this link, then you can traverse there. Then you have a link, then you can traverse there. Then you have a link, you can traverse there, and you have a link, you can traverse there. So that means you should start you should start using the starting point. So in linked list, but basically starting point is called head. So head of the linked list. So head basically contains the starting point of the linked list. So you start with the head informations, then you use all the links informations, then you go to all the next all the next nodes. Okay, so for example, you want to find 3. So in your linked list, you want to find 3 in your linked list. So you start from here, so you come here, and you see that this is not a 3. So you go to the next node, and you check that this is not a 3. Then you go to the next node, you see that this is not a 3. So you go to the next node, then you find that this is a 3. So you can return your results. So this is the way how to search something in a linked list. So that basically you have to traverse all the nodes. But probably you might need to traverse all the nodes in the linked list to find something. Okay, so this is the way how we can search in a linked list. So like in array, you don't have any index, so you cannot easily access any data in the linked list. So that means in order to find any data, in order to retrieve any data, you have to traverse from from starting point or head point to the your targeted node. Okay, so you can there is no any straightforward access method like in array. So this is a limitation of linked list. If you want to find something, if you don't and then you need to traverse everything. So in array you don't need to do that if you have index informations. Now let's see some insertion and deletions operations. We know that insertion and deletion operation is not efficient in the array, because you need to, if you want to insert something, probably you need to shift everything. So if you go to the some program, some pictures. So for example, you want to insert something in between 1 and 2. If you want to insert something 1 and 2, then what you need to do, you need to shape this one first, you need to shape this one first, then you need to shape this one first, then you need to shape this one, then you need to shape this one, then you have a room, then you can have, you can have another elements over here. So shifting is, so we have seen that shifting lot of elements. So shifting lot of elements is not an efficient process. So when you have millions of data, and if you need to shift all millions of data, then that it will take a lot of time. So this is one problem when you try to insert. And there is another problem of deletions also. So if you want to delete this one, so for example, so you delete this one, so you need to shift this one, you need to shift this one, you need to shift this one, and you need to shift this one. Okay, so this is not another, this is another problem. So this is not an efficient process. So if you have millions of data, then you have to shift everything. So this is not a good idea. So that's why we have the linked list. Linked list doesn't have this kind of problem. So we'll see those solutions in the linked list. That let's see another problems in an array. Say for example, you have a only 6 space in this array for inserting. Now you want to insert one more data, but you don't have space in an array. What you need to do, you need to create another array. Then you have to copy all of them, and you need to create bigger array. Then you need to copy all the elements from the old array to new array. Then you can insert a new element. So you can see that creating a bigger array than copy data from the old array to the new array, this is kind of a extra process. So if you should always consider that you might have millions of data. So if you have millions of data, then copying data from old array to the new array, millions of data, copying millions of data is not a good idea. So this is another problem in an array. So we want to overcome this kind of problems by using linked list. So how to insert a node into linked list? So let's consider this one is a linked list. So we know that head is the starting point of a linked list, and tail is the end point of a linked list. So why you need a tail? So probably you want to add some node at the end of the linked list. So in that case, if you have tail informations, you don't need to traverse whole nodes. You just find the tail informations using constant time. Then you can add a new node, and you can make a link from here to the new node. So this is a good idea. Always keep some tail informations. If you want to add any node at the end of the linked list, then you don't need to traverse to find the tail, last node. So if you don't have tails, so if, say for example, if you don't have tails, so what you need to do, find the last node, because you don't know address of other all nodes other than head. So you start from here, then you go there, then you go there, then you go there, then you go there, then you find the last node. So in order to find the last node, you need to traverse the whole linked list. That's not a good idea. So if you keep the tail informations, then you probably can easily jump to the tail, and you can add easily new node over there. Okay, the question was how to insert something in your linked list. So for examples, if you want to insert something, if you want to insert something at the beginning of your linked list, so you want to insert something over here. So let's make some place over here. Okay, make some place over here. Oh shit. Okay. Okay, so make a room. So let's we want to insert a node over here. So what you need to do, so you just need to create a node. So you just need to create a node. So we just create a node. Then what you need to do after creating a code, we just make a link. We just make a link to the head. So we know the head informations. Then we create a link from the new node to the head. So for example, so we make a link from new node to the head. So now you have another new node before that one. So the what is the next step? So now this is not any more starting point. The our new starting point is this one. So you have to assign head by new node. So now this is your head. So there is only three steps. You create a node, then make a link from the new address, new node to the current head. Then you change the old head to the you change your head positions. That should be the new node. So this is only three steps. So you don't need to traverse. You don't need to shape anything. You just create node, because this is not a contiguous, this is scattered, so you can use any space in your memory of the systems. So you can see that you didn't need to shift anything. You just make a node, make a link, and change the head informations. Now let's try to insert a let's try to insert uh, something uh, in between two nodes. So for examples, what you need to do, for example, you want to insert a node in between these two nodes. In between these two nodes. So if you do this case, this sort of things in an array, you need to shift everything. But here you don't need to shift anything. What you need to do, you need to create a node. So this is your new node, and you make a link. So say for example, so you have a link from here to here, then you have a link from uh, 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 then here to here to here, here to here, and you delete this link. So now you can see that you start from here, you come here, you go there, you come here, you go there, you go there. So you already have inserted a new node in between two nodes. You didn't need to shift anything. So you just what you did, you just created a node, and you make a link between these nodes, using the previous node to the new node, using new node to the forwarding node. Then after creating a link, then you delete the previous node. So that's just only three steps. You created a new node. So you can see that this is a quite efficient, that you don't need to shift anything. Now let's talk about deletion. So this is all up to the nodes. So now if you talk about the deletions, say if you want to delete this one, hate. If you want to delete this one, what you need to do, so you just remove, you just make your head, you just make your head to the second positions, because you want to delete this one, and it will be your starting point, and delete these links. So if you delete these links, and it will be a garbage, the computer will, our system will remove these things from our memory of the systems. Now starting point is head, and this one. This is no more a part of the linked list because there is no any link. So this is how you can see that how easy is that. You don't need to shift anything, you just delete link, and you just make your head to the next positions. So this is one kind of deletions if you want to delete the head. Now if you want to delete something in between two nodes, say for example you want to delete this one. So if you want to delete this one, what you need to do, so you need to make a link. So you need to update your link. Say for example this is your link. So what you need to do, you need to delete this, you need to make a link, update your link from here to here, and you delete this one, and that's up to that's so easy. So you just update this link to there and remove the previous link, then you will have 1 2 then 3 and 4. So there will be no link with this node, so this will be treated as a garbage. So our computer will remove these informations because it's a garbage. So you can see that how easy it's that, how easy it is. So you have to just update your link, then you can delete a node. So this one is your concept of linked list, how to insert things, how to delete things, how to search things, so for your single linked list. So now we'll see some implementations, then we'll go for the double linked list, then we'll see some double link in implementations. Now let's talk about double linked list, single linked list, some linked list details. So this one is a linked list. So before going implementation, let's introduce some methods in the linked list. So a linked list in your Java library, so similar to the array list in your Java library, use java.util, you have excuse me, you have a linked list class. That linked list class can be used to create a linked list in your on your terminals in your programs. But if you don't want to use excuse me, if you don't want to use linked list class, built-in linked list class, you can obviously you can create your own linked list class and you can have all the methods. But if you don't want to create your own linked list class, if you want to reuse the Java's libraries linked list class and their method, then you just use linked list class, create object, and you can access all the method of the linked list class. So it's similar to the array list, that a linked list class, like array list, is implement list interface. So that means it contains all the method found in the array list. So you can have all those method in the linked list class also. So these are the method. If you use linked list class, or if you are going to implement your own linked list class, probably you need this sort of method. These are the basic method that you can access from the linked list class, or you can implement those method in your own linked list class. So first method is add method, and you want to add something, add something into the linked list. So add method, so insert an object into the list at some position index. So you are giving some positions. So what is the positions over here? For example, if you give position 3, so probably you want to insert something after 3 nodes. It's something like that. You count the nodes, and because there is no index like in the array, so you have to count the node. When you find the number 3 nodes, then you can insert new node after 3 nodes. So this is kind of an index. So if you want to add something, add a node at some position, then you have add method. So you have add first method. Add first method means you are adding at head positions before your current head. So you will have new head that we have seen in our example. So you just create a node, then you may update, create a link from the new node to the current head position, then change the head to the current node, new node. So add first is the idea, insert an object as the first element of the list. Then add last. If you want to add something after tail, if you want to add something after tail, add object at to the end of the list. So you have it, if you have a tail informations, you can easily find the tail node, then you can create a node and make a link from tail, current tail to the new node, then change the tail positions. Then get first is basically you are retrieving the head informations of the head node of the linked list. You get last means you are you are retrieving the tail informations, tail node, or last element of the list. And the remove method is means you have some object, you find that object, then remove that node. For example, you have 5 nodes, then you are that 5 nodes contains A, B, C, D, E, and you want to delete D, then you have to start from the starting node, head, then you traverse all the nodes, all the nodes until you find D. When you find D, you remove that node and make a link from C to E because you just remove D. Then size basically give the how many nodes you have in the linked list. So these are the basic method that you need for linked list. Let's see our implementations. Let's see some implementations on terminals. I don't know. It's stuck. Okay. So you have seen that we at first what you will see that how we can uh, write our code to create a linked list. So we create a linked list for KW single linked list. This is uh, our our own single linked list. So now, so when we implement a linked list, the important thing is that uh, you have to have some node class. What is node class? Node class create nodes. So if you go to the example, you can see that whenever we do some operations, we basically whenever we do some insertions, so what we need to do, we need to create a node, and after creating a node we add that node to the linked list. So we have two different class. The first class is creating a node, and second class is adding that node to the linked list. So this is two different information, so two different class. So you have to think about the node class also. So go to the node class, so you will have node class. So node class has two members, one is data and another one is reference that of next node, address of the next node. You can see that every node has two informations. This is data and this is address of the next node. This is data, this is the address of the next node. This is data, this is the address of the next node. So every node has two different informations. One is data, another one is address of the node. That's why we have two members of the node class. Then we have a constructor, node constructor. So we can have two different node constructor. One node constructor take data, and that data will be assigned to the data member, data item will be assigned to the data member. And if you are not having any address of the node, your following node, then the next, that is the member that contains the address of the next node, will be null. So initially it will be null if you use this constructor. Now you can have two different constructor. We know that we can have multiple constructor with the same name. So this constructor has data item plus node reference. So this contains the address of the next node. This contains address of the next node. So this data item will be assigned to the data, and this node reference address of the next node will be assigned to the next field. So now, so you can have two different way to create a node. So one way to create a node that you will have data and you will not have any next node informations. And another way to create a node is that you have the data and you have address of the next node also. Okay, so this is how you can create a node class. Now you have to create the in your linked list class. So our linked list class name is kw single linked list class. So we can take any type of data that basically depends on what are the data we want to keep in the linked list. Okay, so we must have some head variables, node type variables, that is called head, that we want to keep our head informations, our starting point information. So if you don't have starting point informations, then maybe we will not find our linked list, any data of our linked list. So even you can keep your tail informations also. So you can keep tail information, something like that. Initially it will be null, then you can keep your tail informations. Okay, so head informations and tail informations. So and size basically keep how many nodes you have in the linked list. Initially it's a 0 because you don't have any node in the linked list. So these are the method. So that add first method, add after method, remove after method, remove first method, get node, and some other things. We'll talk about that things. So for example, so you have the add first method. So add first method, what they are doing, add first method basically create a node, create a node and add before the current head that we have seen in our program. So if you go to that uh, uh, if you go to that file, so if you want to add something before head, if you want to add something before head, and that's basically the method called add first method. So we create a node by calling the constructor, by giving item our data and the head, that is your reference node, that is the address of the following node. So this would be your following node of the new head. So after creating a node with this constructor, then you assign these new node informations to the head variables. So you will have head variables, new head variables, that is your new node. That means you create a node using these head information, that would be your following node of your future head, then assign your new node to the head variables. So that we are doing, we create a node using the data and the current head informations, because current head would be the following node of our new head. Then after creating the node, then we assign that into the head variable. This is very easy to creating add first. This is add first method. Now add after method is you are going to add something after one method, for example, or one node. So for example, you want to create a node after this node, you want to create a node after this node. So this is kind of another things. So you have to so this is your node, this is your reference node, this is your reference node. That means this is your node that you want to create a node after this node. So this is your node, that basically this is your node, so your reference node. So node.next means this field, this is our node, and this is node.next means this fields. So we are assigning into this field, what we are assigning into this field, we create a node, then we make a link from new node to this node, and after creating a node, we assign that new node to the node.next. So that means we create a node, then we make a link from new node to there, and then we assign that node to this node.next, then you will have another link from here to there. So these are saying that these are happening over here. You create a node, when you create a node, you're passing the data and the node dot next information. Node dot next information basically, take the address of this node. Take the address of this node, because node dot next contains the address of this node. So you passing this address of these nodes to create the node. Then after creating a node, you assign the new node informations to the node dot next. So to the these fields, you are assigning the new node information to the new field. So you will have something like that. So if you consider this is your node, so you create a node, then you assign a you assign, you pass node dot next information, that is a basically address of this node, that basically create a link from here to here. Now you assign this node to the this link. So when you assign this link to the this node, that basically delete the previous link and create a new link. That deletes the previous link and delete the new link. When you assign this node address to this one, that the previous link will be deleted and new node will be assigned to there. So this is how uh, add after happening. Now go to the slides in a terminal second. Now remove after is that you have some node informations, and you want to delete something. You need to delete the following node after this node. This is your node reference. So what you need to do, you just keep your following node informations to some temp variables, and if temp is not null, that following node is exists. If temp is not null, then node dot next will be assigned by temp dot next. So and you decrement the size because you just deleted one node. So what he is doing, so you go to that slide. Say for example you want to delete this one, so you have a temp variables. You have to temp variables, say temp variables. In temp variables, you have this, you want to delete this one. Say for example you want to delete this one, you temp variable, you keep this node, you keep this node, you keep this node. Now what you need to do, you need to do that temp dot next. This is temp dot next basically contains the address of this node. Temp dot next, so we copy this one to here. So dot next means next field. So temp dot next field contains these node informations that will be assigned to node dot next, because node is our reference node. So if you copy contents of this information to there, so what you are doing, so these field contains address of this node and this field contains address of this node. Now if you copy contents of this node to there, then you are basically creating a link from here to here, and you just delete this one. You just delete this link because you are copying this here to here. You just delete this one. So this is happening over here. So if you just copy the node.next over here, and node.next is assigned by the temp.next, so this is basically deleting this one. Now remove fast is uh, uh, remove fast is how to remove head. So we have seen that how easy it is. So you have to check that your head is not null. If head is not null, then your head will be your head dot next. That means what you are doing. So if you go to your previous stage of the linked list, so this is your head. So head dot next is this one, and this is the address of this node. So head dot next will be your new head. So head dot next means this one, this node. So your head dot next will be your new head, and when you will have this one, so you always start from here, so this will be as a garbage. So that means how easy it is this. So you remove first means you just, if head is not null, then head will be assigned by head dot next. So this is how is happening. Now then you can have if you check some temp variables. The temp is the contains the head informations. If head is not null, then you just decrement the size of the linked list. So we'll discuss some some other code in the next slide. So far we have seen that how to add uh, at the beginning or at first, how to add in between two nodes, how to remove after, how to remove after some node, and how to remove the first things. So we have seen how to insert something and how to delete something. Okay, so we'll see some next slides, so some more implementation of the linked list.